Alrighty, ladies and gentlemen, right here we are going to be simplifying complex numbers, okay? So remember, when we simplify with the variable I, which is an imaginary value, you just treat it like if it were any other variable, and the only difference is that if you ever end up with the variable I squared, that's where you replace it with a -1. So if we take a look at the problem, 12 minus 22i in parentheses, take away 20 minus 5i in parentheses, just like any other problem, you would have to distribute the minus sign into both terms right there. So you'd end up with a minus 20 and a plus 5i. Now notice that there's nothing to distribute in front of the first set of parentheses, so we're just going to bring that down exactly the way it is. 12 minus 22i. So we have 12 minus 22i minus 20 plus 5i. And then after that, it's just combining like terms. And remember, you want your real number first. So let's combine the 12 with the minus 20, giving us a -8. And then the imaginary numbers is what you want to combine. Combining the -22i with the positive 5i, giving you a -17i. So this is your answer for that question right there. Let's move on to something more entertaining with imaginary values. Right here we are distributing, we're distributing and combining like terms if possible, but we have both radicals and imaginary values in them. So let's take a look at this and let's distribute. We're going to take this first term, negative square root of 3, and multiply it by positive square root of 2. So you have negative square root of 3 times positive square root of 2. First of all, a negative times a positive is a negative. And the square root of 3 times the square root of 2 is the square root of 6. You could actually put those together, right? And then distribute negative square root of 3 times -i. Well, first of all, a negative times a negative is a positive. Okay, so we're going to put a plus because it's going to be a positive. And if you had any variable times a radical, what would you do? You'd put the variable in front of the radical. That's what we're going to do here. We're going to put I square root of 3. Once again, negative square root of 3 times -i, a negative times a negative is a positive. And the square root of 3 times I, you can't really do that, so let's just rewrite it, I square root of 3. Put your variable first and then the square root second. So we've distributed the first term. Now let's distribute the second term, the positive 4i. Positive 4i times a square root of 2, that's kind of like multiplying this by whatever value's in front of the square root, and there is nothing, there's a 1, so you're just going to write them together, 4i times square root of 2. And that is a positive, right? Positive times a positive is a positive, 4i square root of 2. And then 4i times -i, well, a positive times a negative is a negative, and 4i times another I is 4i squared. And just for the sake of making it more visual to you, I'm going to put the I squared in red because we know that we need to replace that I squared with a -1. So let's replace the I squared with a -1. What we're really going to have over here is -4 times -1, thus giving us positive 4 at the very end. So what we have here so far is -6, actually negative square root of 6 plus I square root of 3 plus 4i square root of 2 plus 4. And notice that you cannot combine any of those, right? You cannot combine the square root of 3 with the square root of 2. They're all different. That was kind of ugly. Let me fix that. There you go. So there's your final answer. And as you could see, that is this option right here. Okay. Does it get more fun? Yes, it does. Here's another problem that has both square roots and imaginary values. Right here we need to simplify, and what we need to remember is that whenever you have a fraction, you cannot have square roots or imaginary values in the denominator, okay? And I hope you remember back when we actually learned this, to get rid of a square root in the denominator or a complex number, a binomial with an imaginary value, you have to multiply by the complex conjugate, by the conjugate of whatever binomial you have on the bottom. So you have the binomial 3 minus I squared of 2, we're going to multiply by 3 plus I squared of 2. It's the same identical binomial, except you change that middle sign to a plus. And what you do to the bottom, you must do to the top as well. So 3 plus I squared of 2. So it's kind of like doing two separate problems, right? You're going to go 5 times 3 and then 5 times I squared of 2. Might as well write the numerator answer here, 15 plus 5I squared of 2. That's what we get up on top. Let's work out the bottom right here. When I go 3 times 3, I will get 9. When I go 3 times I squared of 2, I will get positive 3I squared of 2. You're just putting it together. When I distribute negative I squared of 2 times 3, you're just going to put it together, right? Organize it. It's going to be a negative times a positive is a negative 3. Organize it, I squared of 2, right? All I did was put the 3 first, and then the I, and then the square root of 2. 3I squared of 2, and a negative times a positive is a negative. Last but not least, let's distribute negative I squared of 2 times positive I squared of 2. So what is a negative times a positive? It will be a negative. And what is I times I? It'll be an I squared. And what is the square root of 2 times the square root of 2? That is the square root of 4. So that's what we have on the bottom so far. We still need to combine like terms and simplify. Now, what do I mean by combine like terms? Well, when I take a look at the middle terms, the positive 3I squared root of 2 and the negative 3I squared root of 2, those are the identical values but complete opposites. So one's positive, one's negative, which we know that causes it to completely cancel out. Another thing that's very important is that we end up with this I squared, and I squared is really a negative 1, okay? But don't forget that there's this minus sign that has to be in front of the negative 1. And not only this, guys, we also have a square root of 4 that we need to multiply by, and the square root of 4 is really actually 2. So what do we have here? We have a minus 1 times 2. And we know that minus minus is really plus. Plus 1 times 2, that's a positive 2, plus 2, right? The middle terms ended up canceling out. The only thing we have left is the 9. So we really have a 9 plus 2 giving us the answer 11. And this is all on the denominator. The 11 is in the denominator. So we did our work for the top up here, and the 11 is on the bottom. So let's put that over 11 on the bottom. Now that's our answer right now. Let's check and see if they wrote the answer like that, or if they actually split it with the 11 on each of the. It looks like they wrote it with the answer all over 11, which looks like would be this correct answer right here. This guy right there.